Hi everybody, welcome. You should be seeing my screen and hearing my voice. Today's Rubin Science Assembly. We're just doing a little choose your own adventure, something easy, something informal for today. Choose your own data preview one adventure specifically. So we're going to start as always with some announcements and then we'll get into it with the tutorial slash the adventure. As we go, questions are welcome at any time. I can see whose hands are up. I can see the chat. Um, yeah, so just pop something in the chat. There's lots of Rubin staff here, so we can get those questions answered as we go. For announcements, these are a couple of, in case you missed it, RubinObservatory.org has all those Rubin first look images from a couple of weeks ago for you to explore if you want to. In case you missed it, Data Preview 1 was released Monday, June 30th. All of the documentation is at dp1.lsst.io. In case you missed it, the Rubin Data Academy was last week. You can find all the slides and the recordings at the Data Academy website. And all the content, like all the hands-on tutorials that were used in the Academy are all just the DP1 tutorials. There's no special content. So you can find, if you're browsing the tutorials, you would find everything that we used for the Academy in there. For looking to the future, when you want to see all the upcoming events, they are listed at rubinobservatory.org and our For Scientists site. The upcoming Rubin Science Assemblies next week is regular drop-in office hours for Q&A. Bring us your problems, your issues, your questions. Then Thursday, July 24th, we'll do another tutorial. This one will be a little more advanced. A lot of the Academy tutorials were pretty basic, aimed at getting people started, aimed at getting them familiar with the DP1 data sets. So Thursday, July 24th, we're going to do source detection and force photometry. So a little bit of image processing and analysis. Then we will take a break until probably around mid-September. So we'll come back with more programming after Labor Day. Also coming up at the end of this month, it's the Rubin Community Workshop 2025. It'll be July 28th to August 1st. We're back in Tucson this year. It is fully hybrid. The virtual registration is still open, but the in-person registration, we just hit the limit. So in-person registration has just closed. If you're already registered for in-person participation, there is still some space for posters. The form is still open. You'll find it linked from the website, or just email me and let me know if you want to put up a poster. That would be great. All right, just in case this is your first ever Rubin Science Assembly, and you're totally new here, this is just a page of the quick links, mostly stuff I mentioned before. If you don't have a Rubin Science platform account, head over to rsp.lsst.io. It has it getting started. You do have to have an RSP account in order to access the data or do any of the tutorials that we're going to do today, and it can take a few days for things to get set up. For everything related to Data Preview 1, it's dp1.lsst.io, and then we have that rubinobservatory.org website for general information. And whenever you run into issues or you have questions or you need help with something, it's community.lsst.org is the place to go. All right, just a few more announcements. Remember that you do have a users committee. They're there to advocate on your behalf. They like to hear from people who are using the Rubin Science platform. What's good, what's not, what do you need for your science? And I want to point out that the next meeting of the users committee, which will feature a listening session where they want people to come forward and say how they're using the RSP and whether it's working for them. That's going to be at the Rubin Community Workshop. It's on Thursday, July 31st. It's at 10:30 a.m. and the RCW is hybrid. So if you're not registered yet, you can just register for virtual participation and attend as many RCW sessions as you want, including the users committee meeting. Link Frameworks. Link is a sort of a third-party software development project where they're making lots of LSST applicable software. They have an office hour that's usually right after the Rubin Science Assemblies. Today, it's actually not an office hour. It sounds like a pretty cool talk on comet catchers, which is a Zooniverse program that's based on LSST data. So if you like comets, you like citizen science, head over there after this session. All right, that ends announcements. Let's get into today's adventure. The first thing you'll need to do is select one of the 7 Data Preview 1 fields for your adventure today. You can take a quick peek in the documentation. There's an overview page. Let me get you these links. I could play full screen slideshow, but I want access to the links that are in here. Or was that a request to please play full? Well, I want to switch between tabs though, so I'm going to stay in the, I can do this though, make it a little bigger. There's a page in the DP1 documentation that has an overview of the 7 fields. It's got their RI index, it's got the filter breakdown, it's got the number of observations and the number of tracks, like areas for each of the fields. And this table here kind of gives you a rough idea of the 7 fields and how each one was covered. So the point here is to just pick one of the fields that is most closely matched to your general science interests. For example, I do type 1a supernovae, I do extragalactic science, and so it was the ECDFS field, the extended Chandra Deep Field South. It's got all the filters, it's the deepest field, and it has the most observations. So if it was my adventure today, I might pick that one. If you like crowded fields, probably 47 Tuck or the Fornax dwarf spheroidal would be for you. If you're Stars Milky Way local volume person, the low galactic field would make sense. If you're here from solar system, the low ecliptic latitude field probably be the one that you choose today. And if you like nebulae or just sort of general messes, the Seagull Nebula would be the one that you pick today. So let's do first selection that you do have to make for today. Any questions about the various fields? I'll just give you a moment to consider which field you might want to focus on today. Look at the data. Ask questions if you have them. All right, while you're thinking about that, the other thing that you do have to consider for your adventure today is whether you more often use the notebook aspect or more often use the portal aspect. For the tutorials that we have prepared for that, all these tutorials do is just explore the data that was taken for one of the 7 fields. We have notebook versions of the tutorials for all of the fields, but we only have portal tutorials right now for 2 of the fields. So if you are always a portal user, you never use notebooks, you're not a Python coder, I'm sorry, today you will be needing to select between either the galactic, low galactic latitude field or the Seagull Nebula for your adventure, because we only have those 2 in the portal. But once the tutorial is over, you could easily repurpose the tutorial and just do the same set of actions but for a different field. So that is what you're considering, and that is what you're choosing. You're choosing one of the 7 fields and whether you're going to be using the notebook or portal aspect. Any questions at all about that?
So, Melissa, you want us to be logging into the data platform to make this choice, or
You just have to make it for yourself now, and
yeah,
then I
okay,
want to see who wants to do what, and then we'll set up some breakout rooms and stuff.
okay.
So yeah. So yeah, you can start logging in to the notebook aspect now. Mostly I thought people would have more questions about the fields themselves or how to choose one, or like what the data was taken for the different fields. Maybe you're all ready to go. I can see some people. Okay, yeah, people are making their decisions. They are ready. Okay, great. I can see in the chat. Thank you, guys. All right, and so at this point, we could all stay together and sort of go on similar journeys in the same room, or we could break out into Portal. So the first question is, of the Rubin staff that we have here, is anyone prepared to lead a portal room and could lead people through one of the portal exercises?
I could, Greg and do you want to do a portal
Yeah,
room?
I can join in, although I did not really play yet with the 300 series portal tutorials as of yet. But, you know, maybe that can be our adventure.
Okay, thank you for volunteering. Maybe do we have other Rubin staff who are here who could do the notebook versions in the main room? Because I could do the portal versions in a breakout.
I could do any of the notebooks that anyone wants.
Yeah, that would be great. And there's only 20 of us. So I think just 2 breakout rooms seems fine. It's not like we have 100 people here today. Oh, Yumi, crowded fields theme. Yeah, actually that might be nice. Let's do one room that's notebook general. Portal room, I will go help with that. Notebook, crowded fields, because I did see some people in the chat say they were interested. We'll have Yumi lead that one. And that kind of, I think that's probably enough. We don't want to split into too many. And that kind of, yeah, so if you're doing the notebooks for Fornax or 47 Tech, join Yumi. If you're a portal user, join me. And then for everything else, you're just doing any of the other notebook ones. They're all very similar. Stay here in the general room. Okay, let's do that. I'm gonna make 3 breakout rooms.
All right, I see like at least 3 votes for the low ecliptic latitude
Oh,
field, so maybe that's a good topic for the main room here.
yeah, you could pick any one because they're all very identical. So here in the main room, yeah, whoever's leading can pick one of the tutorials, and then everyone else here is free to pick, your own field. The notebooks are identical, it's just they do different fields as they work their way through. So Jeff, are you suggesting one more breakout room or?
No, actually, you're right. Since they're all identical, people can just go through them together in the main room.
Yeah, I think that'll be okay. It's really the Fornax and 47 Tech are a bit different because they're so crowded. So that's why we'll have. But then the rest of them are, well, except the seagull. Someone should pick the seagull. I wrote that one.
You might make an extra breakout room or 2 if possible, just to if anyone wants to have a conversation about the data.
That's a good point. Always have an extra.
So Pat had a question in the chat about the DP1 paper or website.
Okay, yeah, sorry, I was making breakout rooms, not looking
Oh,
at the
oh.
chat. Question, is there a particular section of the DP1 paper that goes into more detail in the fields, more particular science fields of each field, information on other surveys that have covered these fields, etc.? No, maybe the paper does. I have not looked at the final version of the paper in a while.
I think there's a little bit. I'm not sure there's a lot of detail. I have it printed out right here.
Yeah, I was scanning through it, and this is partly in preparation for the desk meeting the week after next and potential D-School lesson on this. And I think this is a question a lot of people have is, inside information on why I should look at that field. I think that kind of thing. And I was skimming through the paper too, and didn't see an obvious section on it. A lot of it is on, how many visits and filter, which filters, things like that, but not so much on the kind of science motivation. Or even if afterwards, if I could get information on who might be a good expert on that we might be able to have them just call in even briefly to our D-School lesson, that would be useful.
Yeah, I think the 7 fields were chosen, like ECDFS is definitely the one that's a classic deep field. If you're, it's been studied, looked at many, many times, the extended Chandra Deep Field South. And then Euclid is the other deep field. So it was done, if you're going to be doing, overlaps with Euclid, you pick that field. And then from there, it's just the crowded fields were chosen because they're crowded. They wanted to really test the data management pipelines. So that's the motivation there, crowded fields. The nebula, of course, you're testing background subtraction, diffuse structures, the ability to do, background subtraction and source detection in a nebula with the seagull. And then low ecliptic latitude is solar system. So really, yeah, it's this and this tutorial that Andres put together is probably the closest thing to what you're looking for, which is it's the 300 level in the 301 series. That's all our target exploration. And it's an overview, and he's got like a nice science description for each of the fields, and that's where this little table came from. So this is the closest thing I've seen anywhere to what you're looking for, Pat.
Okay, thank you. Yeah, and he would be a natural person also for us to bring in by Zoom to talk about this. So thanks a lot. I think this answers my question. Yeah.
Okay, perfect. Yeah. All right, rooms are open. So you can go ahead and join the room of interest. If you're having trouble changing rooms, let me know in the chat and I'll send you where you need to go before I join the portal room.
I can join you in the portal room, Melissa, but if anybody needs to have any specific questions answered, I can probably go into the extra room if necessary.
Yeah, don't go into the room of requirement by yourself. Hi, Tom, I see you. I'm going to move you to crowded fields. Anybody else need to be assigned to the room if you have trouble, like if you're joining from a tablet? Okay, I think everyone's made it where they need to go. So thanks, Douglas. And Jeff, you can take it away in this room. Did I turn recording on? Yeah, I did, right?
Oh, I think you did, or I don't know.
Mine says recording, so yeah.
Great. Okay, thanks. Mine does not say that anymore. Okay.
I'm slightly confused. Was the intention the notebooks were main room?
Yeah.
Okay, because there's
Unless you
also,
are a crowded fields person, then it's
okay, but I
notebooks
think you also made a notebooks breakout. That's
For,
Um,
what I'm,
for the there's a notebooks breakout for the crowded fields, and then there was the extra room, which
oh, because of how I write it on the shoot, I made 4 breakout rooms instead of 3 because I'm not paying close
right.
enough.
So I was wondering about the notebooks general thing.
Right. Right. That's listed, but I shouldn't have made that breakout room. Okay, let me go in there and tell everyone to get back into the main room. Hold on, I'll be back.
Okay.
Oh yeah, I guess that is an issue.
So do you want to be the driver, Douglas?
Yeah, I can be the driver. Let's wait
Awesome.
until others rejoin. I'll take a keep an eye on and see how. I think we still have Valeria. Oh no, Valeria's just rejoined here. Okay. Okay, so welcome to the general notebooks room. I'm not sure. Do we want to just go through a particular notebook, or would people like just well, I guess you've all chosen your adventure, as Melissa put it.
Yeah,
I could go.
pick
Oh,
one.
okay.
Pick your adventure, and then everyone follows along and does the same steps in their notebook as you.
Oh, and their adventure. Okay, that sounds good.
Exactly.
Okay. All right. So let me share a screen here. Let's see. Okay, and I will show meetings so I can see people better. Okay. So all right, let's if you haven't already gone to data.lsst cloud, let us all go to lsst.cloud. So we had okay, a little bit of information. There had been a little bit of issues with some downtime with some of the RSP instances, especially for the project one, internal one. One of the things is if you we're not looking at this at the moment, but if you're looking for DP 0.2 images, they're still offline. But everything else should be fine. But we had a little so having some continuing issues with DP 0.2 image services. But that doesn't, well, we're not looking at DP 0.2, that's the past. We are looking at DP1, and that is all okay. So we'll go to notebooks. Yeah, I should log in. And you'll go through the federated login procedure. If you have problems, let us know. And we're going to go to notebooks. And for those who've been long-term members, before we used to have the notebooks automatically downloaded into a given directory. Now we have a tab up here. We're going to the tutorials, and we're going to go to DP1, and we'll go to the 300 science demos area, and we're going to look at the 301 field explorations notebooks. And Melissa already mentioned the overview by Andres that Pat or chat was asking about the different characters of the different fields. Well, we'll choose one of these other fields. Now the couple of these fields, the 47 tuck and Fornax, those are being discussed in one of the breakout rooms that Yumi is leading. So we can try one of these other fields. Uh, um, Actually, my favorite is the Euclid Deep Field, is either the extended Chandra Deep Field South or the Euclid Deep Field South, because there's a lot of other surveys. There's been other surveys have been looking at these. I think I will. Um, Now, all these are more or less the same, but for just purposes of me having one concrete example to go through, I'll go to the extended Chandra Deep Field South, but please feel free to choose whichever one you wish to choose. They're all more, the format is very much the same throughout for all of these. Um, but I'll choose the extended Chandra Deep Field South. This is a has a lot of data in it from different surveys, and it's nice if you're doing cross-survey work, including X-ray, because the Chandra Observatory is an X-ray observatory. So you'll want to. So okay, I actually was already logged in, but when you logged in, I think the default size you're presented is the large container size and the pipeline versions the recommended is R29.1.1. That should be fine if you just took the defaults. Um, but um, so we so anyway, but moving on. We are going to look at the deep coads, the CCD visits, visits and objects and the object table, and we're using various packages, the RSP package, the Butler package to access data, particularly the image data, and the AFW display, which allows us to display data. Let's see. Okay, let's see. This notebook, okay, I just kind of read straight from here. Okay, we talked a little about the extended Chandra Deep Field South. It's more or less centered at an RA of 53.16 degrees and a deck of minus 28.1 degrees. And the region covers area that spans about a diameter of about 1 degree. So related tutorials, the 100 level tutorials demonstrate how to use the Butler and the table access protocol or TAP service and the Firefly image display. There's also 200 level tutorials that introduce a type of image and catalog data. Let's see, we are going to use, we'll import packages, a standard NumPy and Matplotlib. We're also going to grab a the Matplotlib patches Polygon package, and some other tools for spherical geometry, like the sphere SPH geom and the geom packages, and some plotting tools. So we'll just you can to run each code cell. You can either use the run icon up here, or you can go to the cell, make sure the cell is highlighted, and hit Shift Enter or Shift Return. So, okay, it's that one has run. When it shows a little asterisk in this, it shows it's still in the process of running. But when a number is returned, that indicates it has finished running. Now we will create we'll define some parameters and functions, and we'll start up create an instance to the tap service. So we use this function that we imported up here from the LSST RSP package called get tap service, and we'll assert that the service that's actually returned that it actually is viable. It's actually working using this assert service is not none. Then we will access the Butler for the DP1 data set and import the LSST ComCam DP1 collection within the DP1 data set. And then we will define the approximate central coordinates of the field and create International Virtual Observatory Association, or IVOA, region, or actually a spherical geometry region, from using circle. We're defining a circle region with the RE and deck in the center and a radius of 1 degree. Then we will open up. We'll create colorblind colors for Matplotlib and then define various. Okay, this is something we kind of defined. We have a definition. We actually did this a lot. We had a version in DP 0.2, and then we updated things in for DP1. I know Jeff was heavily involved with this, and Melissa, of arranging just what. Let's see. We have a question from Juan. Users can access data either by TAP or Butler. Why do we need both in the same notebook? So this is true. We tend to focus use TAP primarily for the catalog data and for imaging data. For the images, we tend to use the Butler. It's just to be more efficient that way. There's some description in some of the last week's data academy, which kind of goes into the details of why you use one or the other, or there's some other services like SIA, Simple Image Access Protocol, or the cutout service. There's a cutout service that you can also use. Those are described in, let's see, one of the 100 level tutorials. There's a 100 level tutorial on image. Actually, we can take a quick look here. Go to tutorials, DP1, how to use RSP tools, image and display access, and let's see. I think any of these will kind of, maybe it's 103-1 kind of will say a little bit about, let's see.
Okay, in fact, TAP is recommended for catalogs and
Yes.
Butler is recommended for images.
Yes. It tends to be more adapted for the TAP is definitely tends to be the preferred method, recommended method for catalog access, and Butler tends to be more preferred for catalog access. But anyway, there's more something like in the 103 series that describes when and where you might use the different methodologies. All right. Let's see. We've we define different ways of playing different marker types and colors associated with UGRIZY. And that's sort of kind of built into this get multiband plot colors and symbols and line styles down here. So you don't have to define explicitly what they are. Then we will open up Firefly here. It opens up things in a separate tab. We recommend that you, to be able to view things both simultaneously, you can pull this down and over to the side. And actually, I'm going to close this this panel here to give us a little bit more room here. All right, so let's see. Oh, a little typo here. Okay, so we'll look at for this section. We'll look at the deep coadd, where we've stacked the data from the individual exposures or visits, combined into deep images. So Here we want to grab the data references, or basically essentially like data IDs, that basically the tracked and patch and filter type filter for the coadd image that we want. I shall make this a little bit smaller here for the moment, just so we can see what our query is. We're querying the data sets for images, and we want deep coadds, and we'll use this where clause to look for patches. Recall that for coadds, the sky is tessellated into tracks, and those tracks are subdivided into patches. And the patches are, oh, I forget exactly what size they are. They're roughly the size of a detector image within a factor of 10. I don't remember exactly. So we're looking for patches that overlap that region that we defined up above in this code cell. And we use this bind function to grab the region, and we grab other dimension records, and we order it by the patch and the track name. So we'll run this, and then we'll
Douglas.
count. Oh, sorry.
Sorry, Douglas, what are the dimension records?
These are different aspects of the coadd. So it's like actually, if Jeff is still on, he might have a better memory. Oh no, Jeff's run away. Or maybe Christina might remember better than I do offhand. But it's different aspects of the coadd, like the ARIA and DEC and their extent on the sky and various other things like that.
Sorry,
Basically,
what
what-
was the question, Douglas?
Oh, can you remember what the dimension records are? What all that entails? I don't remember the detail. Don't remember the details all offhand.
Yeah, it's sort of a way of storing the image and its metadata. So I mean, I think you can
So
probably print
It's
them.
it's actually so the way you think about it is that if you have a piece of astronomical information, it has a vector in some space that describes where that information is.
Mhm.
So you have this information space, and there's this astronomical observation in that space.
Mhm.
And it has multiple dimensions. It has the position dimension, the energy dimension, the time dimension, all these dimensions. So those are the dimensions of the observation. Where in space does that information come from? Where in space and time and frequency and all that. So
All right. Okay. Oh, great. Thanks. So okay. Anyway, so we grab this information, and then we can print out how many things that were found. And there were 82 R-band deep coadd images in that 1 degree area that we searched for. Oh, Rachel, you have a question.
Yeah, just sorry to harp on the dimension records point, but just to be clear, is it necessary for that query to execute in cell 8 to include the dimension records because the information is used in the query? Or is it so that the query returns additional metadata that is then useful for analysis?
I think the latter. I'm not
Okay,
because
that's great.
I've seen this query run without that section. I've
Okay, that's
without
great.
without the with dimension records equals true listed there. So
Thank
I
you.
mean,
That's
yes,
helpful.
I have to admit this is the first time I've gone through this particular notebook, these 300 level notebooks myself. So I'm flailing a little bit, but hopefully not too much.
That's great. Thank you very much.
All right, but yeah, I've not actually. This is the first time I saw that. I've seen that actually included in this query. So I'm thinking we probably use it further down in the notebook. Let's see. Okay, now you can use the butler to grab those the images associated with these, and we'll just grab it. We'll just grab a single. So there's 82. We'll grab okay, the 10th and the 0 indexed method. So I guess the 11th, but Python is 0 base. So you start from counting from 0, but we'll grab dimension record 10. We'll grab the images, so image information, deep coadd image, and its information for that particular image. Actually, we could even just, let's see, I can just see what we can see about dimension record 11. Let's see, hopefully it'll give us some interesting information. Okay, so let's see, have the sky map, the tracked, it's a exposure F, which means it includes the actual image and also the mask plane and detection plane and so on. It tells us which processing run it came from. It has it has a detailed, a unique ID associated with that. Okay, so we know something about that particular data set reference for that per image that we're going to grab, image, etc. And it will take a few seconds to grab it. Okay, and then we'll just, okay, I'm going to move this over here because we're about to display it over in the Firefly. So we will display using the Firefly, and we'll set so if you don't, okay, we'll set the mask transparency so we don't see any of the mask plane stuff. So we'll set the mask transparency to 100%. I'll show both. I'll also do a show it with 0%. But okay, here's the image, and the little yellow thing in the middle is pointing to the center point of our initial query. And do lots of different things with this in Firefly of the notebooks in that 103 level series set of tutorials shows you a little more, but you can adjust the scale. It's sort of like SAO image, you can adjust the scale. Strange, if you hunt around a bit, you can find also histogram equalization, which is not really marked immediately here, but you can change the Z scale and with a linear log stretch or a log scale with and so on, or you can change the color mapping and so on. But okay, I'll show you also if you want to show it with the coadd mask fully displayed, with all the mask planes fully displayed. I thought it would. Oh, it's coming up. Here it goes. Yeah. Okay. Here's everything, all the different masks, including the edges of the detector. It's a all as its telescope, so the images rotate in RA and DEC. So all these this grid work of green lines is all the different images that went in, their limits. You can change. Go to over here. You can click on the mask plane here, and you can turn everything on or off. Let's say you're interested in just things which have, let's see, saturated pixels. And if you look closely, you have saturated pixels in green. Maybe you're just interested in the sensor edges from all the individual visits or exposures that went into it. Okay, there's that you have this web, this complicated web here. You have things on the edge, which are basically just along the very edge of, these are in yellow, just along the edge here. You have detected, which is like an SAO image. I forgot what it's called in SAO image, where all the things which are associated with detected shit cells and so on. And so on. Let's see. Moving on. Okay. Oh, let's see. This is new. I haven't looked at this before. There are these these you can grab survey property maps. These are, I think, basically HIPs or hierarchical image maps, in which you can look at the different properties. Let's I myself not really looked at these too much in too much detail, but you can grab the R-band magnitude limit and the exposure time for these. Oh, these are heliosparse maps, sorry. Not let's see. And then you can display these using things to extract parts of the data. Let's see, what are we doing here? We are going to look at, we extract a heliosparse map, values within the radius of the field center, and divide the region into a 250 by 250 grid. Evaluate each survey property map at these grid points. Replace all negative values or no data placeholders with NaN to enable proper map display. So this basically just does all that magic. And we will do that. And I don't see anything. It's going to show up. Oh, maybe. Oh, we aren't actually plotting it, are we? We're just values. I think we're not actually plotting it just yet. I think we are doing it a little bit later. We'll do some cleanup. We'll print some mean and median stuff here for the mean magnitude limit. Our magnitude limit mean and median is about 26 magnitude in R, and the R band magnitude limit magnitude min and max go from 21 to 27. The magnitude limit is like, I think it's a 5 sigma. This is the 5 sigma limit, and this goes beyond to the full maximum detected, which is probably spurious, but we list it anyway. And the exposure time in seconds, and the min and max exposure time over this field. So there's some things right towards the edge, which only had a single visit, single 30-second visit or exposure. And the deepest one is, wow, it's close to 2 hours. So 600, almost 7, maybe hour and a half, hour and 45 minutes there. Then we can, let's see, define, okay, you're going to, what is it doing? It's just doing some weird stuff with color maps. It's doing some matplotlib magic here. Let's see. The coadd data set returned from the Delta include region information for each data set stored as a convex polygon 3D. That's probably why we use that with data sets thing above earlier equals true to make use of this. Okay, convert these vertices to 2D sky currents using sphere point, and then plot each outline. Each track is plotted with a distinct color and line scale for visual clarity. Okay, let's see what this looks like. Oh, okay. Here we're just plotting in the notebook the positions of the patches and tracks. And so there's 4 different tracks covering here in that LST tessellation of the sky. And so we see here where they lie, where the data lie relative to the tracks, and we have the R-band limiting magnitude here, where bright is a fainter limiting magnitude, and dark is a brighter limiting magnitude. So you see things at the very edges are not a very strong, very high limiting magnitude, and things more towards the center have where you have a lot more coverage have a deeper limiting magnitude. Okay, we'll delete all that stuff, and now that's it for the deep coads. We can look at the individual visits or exposures that went into these observations. Any, yeah, we're kind of running a little out of time, but are there any questions at this stage? All right, let's move on to the individual visits or individual observations, the single epoch observations. We call them visits, although they're exposures. There's some still debating about whether we do like for the main survey, whether we do two 15-second exposures and combine them and call it a visit, or just have one exposure equals one visit. For ComCam, it's one exposure is one visit. And that's to kind of detect fast-moving asteroids and things like that. But that's still under debate for the main survey. Okay, here we're creating a query. What are we doing? Here we're using the TAP service to query the visit, the band, the midpoint, the MJD, the modified Julian date, the midpoint of the exposure, and grab it from the DP1.visit table for everything that lies within that RE and we defined for this, and we order it by the midpoint of the exposure. We'll run this, and we're running this in asynchronous mode, which is the preferred mode, and it finished fairly quickly. We assert that a job completed, and we print how many visits were found, and there were 855 visits found. We can take a quick look at the table that was returned, and we have the visit, which is basically, the name of the visit is basically the UT date. So this is November 8th, 2024, and a running ID for that date. And here's the midpoint of the timestamp in MJD for the midpoint of the exposure. And here is here's the same thing, but in a date format. And also we have the filter. You can look at the counts and list of the filters. So we have 230 G band, 162 I band, 235 R band, 45 U band, 30 Y band, and 153 Z band. We'll clean that up and we'll look at the dates. Let's see, running out of time, I'm just gonna go fairly quickly through here, but we'll look at, okay. So here's the cumulative number of visits over time over modified Julian date, and here is the separation between observations for given observations in a given band over. So you had some observations that were observed less than a day apart, and some as much as over 32 days apart, 31 days, 31 or 32 days apart. Let's see. There's image quality. We query the TAP service, and we're looking at the scene for these images. Now, we didn't have really active, or we haven't ComCam, unlike the main camera, we still hadn't had full control of some aspects of the telescope, so the scene is a bit worse than what we'll expect for the main camera. Or actually, what we're seeing for the main camera, we do have the main camera observed. So these are mostly around 1 arc seconds. The median PSS is around 1 arc seconds, a bit worse in G and U band. And some things going.
Douglas,
sorry
to interrupt. A quick question.
Yes.
Comparing the query that you have there for the CCD visit table, and I noticed the previous one queried the visit table.
Right.
I guess what I'm trying to figure out is for any given query I want to do, which one do I decide to query,
Oh.
which table to use?
It depends on whether you're more interested in the full focal plane information or the individual detector within the focal plane information. So here, yeah, I guess the scene is measured as a function, tabulated as a function of each detector. So that's why we use this CC. Yeah, we have a listing somewhere of the data model. I don't have it right here in front of me. I should have, but in the DP1.lc.io, you can find information on the data model and what tables contain what information. So I believe that, but seeing, I believe, is just tabulated by individual detector.
Okay, and it's separated that way because each detector is processed separately and they're stored that
Right.
separately. Okay, that makes sense. Thank you.
Oh, yes. And also, you may expect there's a possibility that you might have slightly worse seeing as you get out to the edges of the let's say, well, maybe not. ComCam is a small detector in the field of view, but also you can maybe at the very edges things may degrade a little bit. I'm not entirely sure. Maybe Jeff might have a better idea. I know for the LCS main camera, you do start getting some vignetting at the very edges of the main camera. I'm not sure whether you get any degradation in the scene though.
Yeah, I think like for ComCam, it's a small enough field of view that I don't think there's usually significant variation between the 9 CCDs. But like on the LSST cam, you can definitely get, gradients of seeing across the field and things like that. But not like super significant, but
Yeah.
0.1, 0.2 arc second gradient or something.
Yeah, definitely there's a little vignetting on the outer edges of the outer CCDs of the main camera. That's been discussed in one of the calibration or data processing channels of the project Slack. Let's see. Seeing bins. Let's see. We're going to look at let's see, what are we I have no idea what we're going to see. We'll take a look at what this next plot the distribution of the magnitude limit. Okay, that looks interesting. So here's the magnitude limit using one here where I guess we're also using the CCD visits. And that makes sense. I mean, more so for the main camera. But yeah, so here are the limits for all the CCDs of all the detectors of all the visits, like that 855 visits split up by filter, and of course, U-band you aren't going as deep as say G-band. Let's see. Oh, objects. Here we look at the object table. We'll query once again query the tap service. We'll probably get magnitude distributions. Oh wow, we have just 2 minutes left. I think I'll probably just leave this. Let's see. I'll just zoom through this. It looks like we get a color magnitude diagram at the end of this. We'll take a look at that. Probably if it gets through in time before the last minute is up. But I encourage people to look through the rest of this notebook or whichever one that you're looking through. A lot of effort has gone into these notebooks, and there are a lot of interesting things. But maybe any other questions or comments before we close for the session? Oh,
Hey, Doug.
Bob, do you have a question?
Not a question. I just like to know who all was involved in doing all this wonderful work of converting the codes to DP1, putting all those tutorials together, because this is really great work.
Basically all the CST members. I know I did nothing. There's a nice color matching diagram. I did none of the 300 level ones, but I know Jeff and Christina here, and Yumi's back now. Other but these 300 level ones, Jeff and Yumi and Christina and others have worked on, and for the portals, Greg and Tina did a lot of and Melissa was hurting us all through this effort.
It's marvelous work. I just really appreciate it.
Well, it's a lot of nice stuff. I'm learning a lot of stuff myself through these. Oh, and the people are definitely advised to go to the link talk, which is starting now. All right. Well, we'll be back again next Thursday, I believe. Thanks everyone. And till next time. And please be sure to use the community forum if you have questions.